What we're looking at today is a very important limit. It's the limit as h approaches 0, f of x plus h minus f of x all over h. And we're going to evaluate this for lots of different functions. For example, let's evaluate that limit for the function y equals x squared. How we do it? We'll start with our limit. We're going to separate it into two pieces and examine those two pieces separately. F of x we know is x squared. So x squared is going to go in places of f of x. Now, how do we calculate f of x plus h? What we're saying is we're putting x plus h in everywhere there's an x. So that x becomes x plus h, and this x becomes x plus h. So everywhere there's an x, we're replacing it with x plus h. So there's what f of x plus h is. And that goes in here. So this entire term, f of x plus h, gets replaced with x plus h squared. This entire term, f of x, gets replaced with x squared. Now we just have a limit. So we should expand this, I think. We can square that out. We get x squared, 2xh, and h squared. And then we look for things we can get rid of. Looks like those x squared will go. A great way to check if you've done this correctly, absolutely everything you put in for f of x will get eliminated. If anything from f of x is left over, you have a plus or minus sign issue. Okay, so now we're left with this. We have a common factor of h that we can take out of everybody. So that'll be h to the 1, and that'll be 1. That leaves us with the limit as h approaches 0, 2x plus h. Let h go to 0, and our final answer is 2x. So let's just take one more look. It's the special limit, the limit into h approaches 0, f of x plus h minus f of x all over h. The specific function we're looking at, f of x equals x squared. We replace x squared for f of x. We replace x plus h squared for f of x plus h, and then we work it out. Let's try another one. We'll evaluate the limit for f of x equals x squared plus 2x plus 3. So there's our limit. We'll look at the two parts separately. Again, to calculate f of x plus h, what you're doing is replacing all your x's with x plus h. So we have an x here. I'm going to replace that with x plus h. We have an x here. I'm going to replace that with x plus h. Whoops. So there's our f of x plus h. I think I'll just let you look at the nice version. So f of x is the same as x squared plus 2x plus 3. So we're going to put that instead of f of x. F of x plus h is the same as x plus h squared plus 2 times x plus h plus 3. And that goes instead of f of x plus h. And then you just do some math. So x plus h squared, we should expand that. We get x squared, 2xh plus h squared. We could multiply the 2 in, we'd get 2x plus 2h. And then I'm going to multiply this negative in. Think of it as a negative 1 multiplied by everything. So we're going to have a negative x squared minus 2x minus 3. So that's where all those terms come from. Now look for things we can get rid of. There's an x squared that's common. There's a 2x and a 3. So all of those get eliminated. X squared minus x squared, 2x minus 2x, 3 minus 3. And once again, everything we put in for f of x, all of those terms have been eliminated, which means we're probably on the right track. What are we left with? 2xh, h squared, 2h, and h. Everyone's got an h. So let's divide out an h out of everything. And then let h go to 0. So I'm getting 2x plus 2 for that. So that's all you're doing today. Lesson 4, 1 to 10. It's a tremendous review of all the rules you've got for evaluating limits. Great practices with this incredibly important limit. If anyone's looking at this going, that can't be that important, yeah, it's very important. So spend the time, make sure you're comfortable with this. You are going to see this again and again and again in calculus. So get good at it. After you finish those, if you want some extra practice, we gave you some extra practice on limits. You can choose to do that or not. All right, have fun, be good.